All right. We are going to verify trigonometric identities. What? Would you rather get attacked by 2 lions or 70 cats? I'll do the 2 lions because I think I would die quicker. The 70 cats, somebody said, well, you just fight them off. 70 cats? Really? You're going to fight off 70 cats? That would be nasty. Okay. Trigonomet verification of trig identities. You have a left-hand side equal to a right-hand side. You must choose to work with one and not the other. You may not do something to both sides. That would be illegal. Watch this. I have the number -1. I set it equal to +1. Is -1 equal to 1? Well, watch this. I'll do something to both sides, and sure enough, I have 1 equal to 1. And so I have verified that when, in fact, we know from the beginning it was not true. So you don't want to do that. You got to work with one side and make the other side, make them look the same. So I need to take this tangent of y. You're always going to work with the left-hand side in this case. Okay, I'll always set them up where it would be the left-hand side. But we can't manipulate the right-hand side at all. So I got to take tangent of y over cosecant of y, which is basically what we did yesterday. The only difference is I know what it turns out to be. I have to make it look like that. Have to make it look like that. What's your first step? What do you want to do? Okay, make it so they're timesing. So we'll do that. I'm going to rewrite it as sine of y over cosine of y divided by 1 over sine of y. Multiply by the reciprocal. See, Taylor, I made these problems for you. Times sine of y over 1. So those are gone. What is sine of y over cosine of y times sine of y over 1? That's not equal to secant of y minus cosine of y yet. They're not the same yet. Any thoughts? I can't deal with the left-hand side or the right-hand side at all. I can't touch it. So it's illegal. It's illegal. Because -1 is not equal to 1. But I can do something to both sides and make it look the same. And you can't do that. Once you commit to working one side, you may not work with the other. Okay. So sine squared, what I am going to do is I'm going to substitute something in. Namely, that sine squared is equal to 1 minus cosine squared of y. I took the sine squared of y and I substituted in 1 minus cosine squared. Question. One over cosine is secant, and cosine squared over cosine is just cosine. So as you can see here, you could rewrite this. Instead of one fraction, you could separate it into two fractions. 1 over cosine of y minus cosine squared of y over cosine of y. What's 1 over cosine? What's cosine squared over cosine? Now the left-hand side looks identical to the right-hand side. Isn't that nice? So this piece right here, well, I got this. Yes. Yes. Any other questions on the first example? Okay, let's try the second one. 1 over 1 minus sine squared. What would you like to do first? Make it cosine squared. 1 over cosine squared. So Parker's working with the left-hand side. He noticed that 1 over 1 minus sine squared is the same as 1 over cosine squared. What would you like to do now? Yes, 1 over cosine squared is secant squared. What do I know secant squared is equal to? Look at your sheet. Look at number 6. I just put a check to say I'm done. I did it. Robin, you have a question. You must ask. I cannot read your mind. Ask it. Go ahead, Robin. Ask it. Somebody ask a question. When you start bringing me something like money. I do bring some of my classes treats. I brought calculus treats last week. I got candy bars for Sammy Klaprick and Jason Apple and Stuart Baleen and Kelsey Thomas, and we did an activity and they came up with the best answer, so I got them a candy bar. Maybe we'll have a contest on reducing trig identities, and whoever does it the best will get them a candy bar. maybe what I'll do is I will bring treats for those who are worst at doing trig identities. So we could have a contest to see. Maybe I'll bring treats for everybody who's just average at doing it. Okay. I might just bring treats for everybody. Okay. All right. Bring brownies tomorrow? No. Okay. C is an excellent problem, and C has the possibility to get you lost somewhere along the way. So I really got to focus here. All this stuff on the left-hand side is apparently equal to negative sine of x. And so we're going to give it a shot. What would you like to do first? Let's multiply. It is factored. Let's multiply. Cotangent times cosine is cotangent of x times the cosine of x. At least we're making progress. You know, when people start to struggle with this, I really encourage them to just start writing stuff down. Just because you don't see the end doesn't mean you can't continue to make progress. Problem D, I wasted a whole sheet of paper on problem D. I was trying a method that wasn't working out. I ended up doing a different method, which is what I'll show you. It works out fine. But, keep working at it. Don't stop using that pencil. Just keep working at it. So cotangent times 1 is cotangent. Negative cosecant times cosine is negative cosecant cosine minus cosecant of x. All right. So I distributed everything through. That's what I end up with. Looks pretty bad, doesn't it? Uh-oh, Parker sees it. What do you see, Parker? The middle cancels out. What Parker sees is this. Cotangent can be rewritten as what? Cosine of x over sine of x minus, how can you rewrite cosecant times cosine? 1 over sine of x times cosine of x over 1. Whitney asks a very good question. How do you just see that? Um, the reason why he saw it is because he was hoping, anticipating that something would cancel. And so he was right. I mean, you were looking for something, right? You're kind of hoping that something would be there. Oh, you did write them all out. Okay, well that's fine too. So he actually wrote them all out like this, Whitney. So instead of actually looking for it, he uh, he was a one step ahead of us in terms of doing the problem. So he wrote it all out, and that would be the other way. You could write every single one out. But does everybody see how I got these two pieces? And you see that they are the same? So they will cancel. Sorry, Parker, I gave you too much credit. I thought you saw it without writing it all out. So I won't overestimate you next time. I'll think less. I'll think less of your mathematical abilities from now on. Okay. So uh, cotangent of x times cosine of x. I'm going to rewrite that as follows: cosine of x over sine of x times cosine of x over 1 minus what? 1 over sine of x. So what does the left portion here give me? So I have two fractions. Do they have the same denominator? So I have cosine square root of x minus 1 over sine of x. Now, do you have cosine square root of x minus 1 on your sheet? No, you have 1 minus cosine square root of x, right? So they differ by a factor of -1. So what we could do is we could rewrite this to be -1 times. So I'm going to factor out a -1. So the -1 will turn to a +1, and the positive cosine squared will turn to a negative cosine squared. Very good, Whitney. 1 minus cosine squared is sine squared of x. We have negative sine squared of x on top, sine of x on the bottom. One of those will cancel, leaves you with negative sine of x. Beautiful. Oh, you're allowed to make animal sounds. What's that, Jalen? Because I factored out a -1. See, this one is positive cosine squared. This one is negative cosine squared. This one is a positive one. This one's a -1. So they differ by a factor of -1. Does that help? Okay. Last problem. And you guys have the rest of the artwork. This last one actually works out pretty slick. Well, yeah. So don't write this down, but I'll show you what I did that is an option, but it's not the correct option. Well, no, because you guys need to realize that, you might start down a path and it might not work out. I did. What I did is I multiplied by the conjugate at the bottom. What's the conjugate is secant x minus 1? Secant of x plus 1. And so on the bottom, I ended up with secant squared of x minus 1, which is equal to tangent squared. So I really, that's what I wanted. I could see I could get a tangent squared on the bottom. But on the top, it got really messy. And It just didn't really work out. And so I went back to a method that is a little bit more basic, but I didn't try it. But it turns out that it's what you want to use here. So this is a really good example. Sometimes if you have a fraction like such, you should combine the elements in the top together and the elements in the bottom together to make a complex fraction. So all I'm going to do is I'm just going to do cosecant minus cotangent and write it as one fraction. And then the bottom secant minus 1, write it as one fraction. So the top looks like this. 1 over sine of x minus cosine of x over sine of x. Agreed? Divided by, the bottom would be 1 over the cosine of x minus, I'm going to write it as 1 over 1. So in the top, do I have common denominators? Do I have common denominators in the denominator? No. So what do I need to do to this 1 to get common denominators? Multiply it by the cosine of x. And again, note, this is, in this process, we're not doing trigonometry. We're doing algebra right now. We're working with complex fractions. Algebra, that subject that we all love, right? That's so easy. It always works out. This is algebra. That equals, on the top, I can write the top as one fraction now, can't I? What is it? Very good, all 5 of you who answered. Good job. And on the bottom, I can write that as one fraction, can't I? What is it? When I have 2 fractions divided by each other, I should multiply by the reciprocal. So 1 minus cosine of x over sine of x times cosine of x over 1 minus cosine of x. And we do see that those cancel. You're left with cosine of x over sine of x, which is cotangent of x. Make a box, put a check in it. You're done. Levi likes that. You like the box part, don't you? There you go. It's not easy, you guys. I do believe it will get easier in the next lesson, though. Go ahead, struggle with them, work through them, push through them, ask questions. Don't feel bad if you don't get one right. Don't feel bad if you have to move on to one. Don't feel like you got to get one before you get the other. They're all different. Dedicate some time tonight, today. It is math time. This is not the time you want to say, ooh, I got other stuff to do instead. This is definitely time where you need to dedicate to math. Good luck.